Good morning, students. In this class, we are going to learn speed control of three-phase induction motor, stator side. In one technique is the pole changing method. In previous classes, we have discussed different methods to control the speed of three-phase induction motor, stator side and rotor side. In the stator side, we have discussed how we are going to change its speed with help of frequency control method and voltage control method. That means we are going to maintain the air gap flux. V by F ratio should be constant with the help of variable frequency and variable voltage devices. In this class, we are going to control the speed of induction motor is another interesting topic, that is called pole changing method. What are the objectives today? On completion of this period, you would be able to know speed control of induction motor by pole changing method. So what we have seen. So on which factors the speed of the induction motor depends, dear students? We know that N, that is equal to 120 F by P. N is directly proportional to the frequency. N is inversely proportional to the number of poles. Not only this one, and N is equal to 1 minus S times of Ns synchronous speed. That means the speed can change with the help of the frequency, with the help of the poles, with the help of the slip. Okay. In this class, we are going to concentrate. This is the method. What is the Ns? Ns is equal to the synchronous speed 120 F by P. N depends upon what factors? Frequency, number of poles, slip. Can we change the slip of the motor? Yes. What is the formula for speed of the induction motor? N is equal to 1 minus S into Ns. Speed control of induction motor by pole changing method. Here, dear students, before, what is the concept? What is the N? N is equal to, Ns is equal to 120, okay, F by P. That means here the induction motor, when three-phase supply is given, it produces the magnetic field that is rotating at a synchronous speed. The flux produced phi r is equal to 1.5 times of phi m maximum flux produced by individual any one phase. So this is a magnitude and rotating at synchronous speed. For example, P is equal to 4-pole machine. So the Ns is equal nearly 1500 rpm. But our rotor tried to catch this one, but due to its some weight and losses, it never reached its synchronous speed. Hence our rotor speed maybe N is equal to 1440 rpm. Okay, rpm. This is the actual speed, rotor speed. This is the magnetic field speed. If the slip speed is equal to Ns minus N by Ns, slip speed. That means 1500 minus 1440 divided by 15. So we are going to get the some slip. Okay. So that means here the slip is playing the vital role in changing the motor speed. Okay. So here the concept, the P is equal to 4 pole. We are going to get the this one, and speed is going to the 14 pattern. Instead of 4 poles, if I place the 8 poles, for example, I can take the P is equal to 8 poles. What is the speed of this one? The speed will decrease to the 750 rpm. Synchronous speed also 750 rpm only. Then automatically the rotor speed is decreased less than the 750 rpm. It may be 600 rpm. Okay, 600 rpm. The rotor speed is 600 rpm, whereas the synchronous speed is 750 rpm. If number of poles increased further, 8 is suppose 16, then the speed further increased to the 750 by 2. That is a 325. If synchronous speed is for 325 ns, then nr is always less than the ns. So the speed may be nearly 300 rpm only. Here what we are going to conclude that if P is equal changes at 4 pole, we are going to get the 1500 rpm. 8 pole we are going to the 750 rpm. If 16 poles, we are going to get the 325 rpm. By changing the number of poles, simply number of poles, so we are going to change the speed. So how it is possible we are going to change the number of poles? So here is the two main method concept. I am going to insert the one winding. This is designed for the P is equal 4 pole, and another winding on this one we designed by the P is equal 8 poles. Okay, so based on number of poles, here if first winding which is designed for the 4 pole machine, so if it is connected to the supply, it produces the 4 poles, then rotor also created its rotor number of poles becomes to the P is equal number of pole, then it rotates at a speed of n. That's the first case. In second case, while connected in first case P is equal 4 pole, the winding which is inside the motor stator winding P is equal to 8 pole, that should be open circuited. Okay, that is the ideal. Now second case, if disconnect the winding which is connected, the number of poles is 4. Now connect the winding which is designed for the 8 pole, and the 4 pole machine winding, first winding is open circuited and second winding is connected to the supply. When supply is given to the 8 pole machine to the stator, the rotor automatically form to the 4 pole 8 pole rotor winding. Okay, this is the beauty of the induction motor. Whatever the stator winding, we are going to change the number of poles, automatically it creates its own number of poles is corresponding to the stator winding. Now rotor winding also created 8 pole machine, and correspondingly the motor will run at some speed. Okay, now if connected the one winding at pole 4 pole, it is rotating at 1500 rpm, a rotor speed 1440. Now it is disconnected and stator winding is second winding is connected to the supply, and it forms the 8 pole. Then speed of the synchronous speed is 750. The rotor speed may be 700 rpm. Such a way that we are going to change the number of poles. That is a one technique. And another technique is by connecting the winding, stator winding, and by taking the number of terminals here, we can form by connecting the number of, suppose T1, T2, T3, T4, T5 number of terminals. So that means we are connecting the number of terminals here. So we are going to connect, so from here, so these terminals, so we are going to form These poles, this winding may be P is equal to 4 pole machine, P is equal to 8 pole machine, P is equal to 16 pole machine. We can connect by connecting the series parallel connection of this winding. That is known as the consequent pole changing method. Okay, here is only single winding. Here is only single winding. So that can connected number of terminals. So then we can change the number of poles. So correspondingly, changing the number of poles, we are going to control the speed. Okay, in bida tiffin time. Okay, here the number of the terminals which is connected here, series or parallel, we are going to change the number of poles. Correspondingly, rotor automatically designed its number of poles. Then we are going to change the speed of the motor. This is a basic concept of pole changing method in 3-phase induction motors. Okay, so it is not possible in case of our DC motors. Okay, let us see one by one. The speed of induction motor is given by N is equal to, the rotor speed is equal to synchronous speed into 1 minus slip, where the synchronous speed Ns is equal to, so whatever the Ns is equal 128 by P. So substitute this in the equation, that one. So we are going to get it. So another equation. So what we are going to get it here. So N is equal to Ns minus this one. So what is the Ns? Ns is equal to 120 F by P, okay, into 1 minus S, that is equal to N. So we are going to this one also. That means we can change the speed depending on the number of frequency, number of poles and slip. Okay, so here at the same time, what is the slip? Slip is equal to, already we know that rotor copper loss is equal to rotor input into slip. So we are going to get it. Okay, so this is the, hence from the above expression it can be concluded that the speed of the motor can be changed either by changing its synchronous speed or by changing its slip. Thus, we know that the synchronous speed is equal to 120 F by P. So Nr is equal 1 minus S into Ns. That is equal 1 minus S into 120 F by P. From the above equation, it is clear that the speed of the induction motor can be varied by changing the number of poles. Okay, so here what is that equation? The N is equal to 1 minus S into 120 F by P. Okay, now here is a relation between our speed and number of poles. By changing the number of poles, the synchronous speed is changed and therefore the speed of the motor is changed. The method is very much suitable for squirrel cage motor only as cage rotor automatically adjusts itself to any number of stator poles. In slip ring, the same arrangement is required on the rotor side to match the stator and rotor poles. The disadvantage of this method is step changes in speed and smooth speed control is not possible. So by changing the number of speed, so P is equal to 4, we are going to 4 pole machine, we are going to get the 1500 RPM. The P is equal to 8 pole, we are going to the 750. That is the gap. Steps are very just like our domestic regulators, fan regulators. Number 1, 2, 3, 4. We changing the number of regulators. So we are going to get the stepped speed. We are not going to the smooth variation. Whereas if you are in case of our domestic regulator, electronics regulator, you can observe it, electron regulator, we are going to get the smooth variation of the speed. Okay. So whereas the manual regulator, 1, 2, 3, 4, 5 numbers, no. So that is we are going to get the stepped speed. Okay, that is the one disadvantage in this case. Now speed control of induction motor. Now let us see. This change of pole is achieved by the following two methods: by using two separate windings on stator winding, that is we can say the multiple stator windings, one or two or three. So but what will happen, so by inserting the extra windings in this one, the size of the motor increases, the bulkiness increases. By using the consequent pole techniques, that means by changing the number of connections, whether the series or parallel of stator or single winding, we are going to form the number of poles. These are the two methods. Okay, dear students, what is happened in this case, by using the separate windings, so this winding, this winding, this winding, that means P is equal to 4 pole machine, P is equal to 8 pole machine, P is equal 16 pole machines. Connect at one winding at a time and keep remaining winding open. That is the first case. That's the multiple stator windings. In second case, in this case what will happen, so what are the winding, only single winding, but take the connections, but connecting the series parallel, so we are going to change the speed. Okay, multiple stator winding. The stator has two separate windings with a different number of poles. Two definite rotor speeds are obtained. These windings are insulated and only one winding is energized at a time. In this method, the stator is wound for two or more independent windings for different number of poles by for 4 poles and 6 poles, and two definite rotor speeds can be obtained. The multiple stator winding, so let us consider the a 4 pole and 6 pole windings on the stator. Then what is happen here, so N is equal to 120 F by P. Okay, so if P is equal to first case, case 1, if this one P is equal to 1, N is equal to, what is that? N is equal, we are going to get the 120 F by P, that is we are going to the 1500 RPM. Okay, now P is equal 6. So second case, P is equal to P, 6 means 2 is a, and we are going to the 120 into 50, P is equal to how much? 6. 6 ones are 6 twos are. We are going to the N is equal to 1000 RPM. Okay, so by changing the, here P is equal 4, here P is equal to 6 poles. Okay, so these two windings are inserted in stator winding. This is a 4 pole machine and this is a 6 pole machine. Okay, NR is equal 1 minus, for example, if the slip S is equal to taken the 3% slip. At that condition, if P is equal to 4 pole machine, so we are going to get the 1455 RPM rotor speed. Okay, so if P is equal to same slip, P is equal to 6, then we are going to the different speed. Okay, NR is equal to 120, then so you can see here what is the rotor speed. Here synchronous speed is a 1500 RPM, but our rotor is rotating at 1455. Here the synchronous speed is 1000 RPM, but it is rotating at 750 RPM with some slip. Okay, so by connecting this winding, keeping this open, we are going to get the 1455 RPM. Second case, by opening this one, connecting this one, and we are going to get the, this is the RPM. Okay, two steps we are going to get it. Assuming is the S is equal to 3% slip, frequency is the 50 Hz. The two windings are to be insulated from each other and kept open circuited. When any one of the winding is used, the other winding should be kept open circuited to avoid circulating current in the winding. If it is closed, it is also producing its own magnetic flux, that is the interference to the winding. In the rotor, the poles are induced in accordance with the number of poles in the stator. That is the beauty of the induction motor. The limitation of this method is that only two definite speeds can be obtained. That is, P is equal to 4, P is equal to 6 poles. And this is a bulk in size. Hence, we are going to some advanced technique, that is known as the consequent pole techniques. In this method, the number of poles can be changed in the ratio of 2:1 by changing the connections of the stator windings. The figure shows 4 coils of the one phase of stator winding with the alternate coils in series and 4 coils connected. So let us see this. You can see the figure 1 figure. So these are the windings. This is one case. This is the first case. This is the second case. It has what will happen. So here the terminals you can see. So this is one terminal. This is another terminal. And here you can see that this is another terminal. And this is another terminal. Okay, so by connecting these terminals, we are going to form it. So, for example, current direction, this is the north pole, and simultaneously it is coming to the south pole. Okay, so you can see here is a 1 pole, 2, 3, 4, 5, 6, 7, 8. This is the 8 pole machine. Okay, now same winding connecting the terminals. So, in the another passion. Then what will happen? The forms. This is the north pole, this is the south pole, this is the north pole, and this is the south pole. How many poles? P is equal 4 poles. So simply by connecting the terminals, you can see what are the terminals you connected. So by simply connecting these terminals, and we are going to get it the number of 4 poles, number of 8 poles. So if the poles are changed, the speed automatically changes. Okay, this is a basic concept, dear friends. Okay, simple connections. Terminals, by connecting the terminals, we are going to form the number of poles. Okay, let us see in details. Now we can see the number of T1, T2, T3, T4, the 2 coils. Okay, each coil having the terminal starting T1, ending T2. Another coil having the starting T3, another ending is a T4. Okay, let us see. So you can see here for the low speed number of poles is 8. Okay, so what is happened here? You can see it. This is a coil A1, this is a coil A1, A2, A2. Okay, so T1 is the terminal starting coil. A1 is connected, the current is entering here, so the current direction is this one. So we can say this is the north pole. And current is coming downward, then we can say the south pole. Similarly, it is connected here, entering here. So it becomes the north pole. Now it is coming to this one is the south pole. Now it is coming here, it's connected and connected and connected and connected and connected. Here once again, this is the north pole. Now coming to this one, south pole. And it's connected here. Okay, north pole and connected here, south pole. It is going to connect end here. Okay, if you connect the T1 and T3, so all are connected in series. Okay, so what is happened here? The north pole, this is a 1, 2, 3, 4, 5, 6, 7, 8. So 8 pole machine is becomes. The speed becomes to the low speed. Okay, 120 F by P. Okay, now P is equal to 8. 4 2s are 4 3s are. Okay, then we are going to get the nearly 2 1s are 2 15s are. 15 into 5. 750 RPM. Okay, we are going to get the NS is equal to 750 RPM. Then rotor speed is less than the 750 RPM. Okay, 8 pole machine. Now, same connection, same winding, whatever the winding inside this one. So we are going to connect change the number of terminals. You can T1, here you can see, once again you can see here, what is that? This is the T1, this is the T2, this is the T3, this is the T4. You can connect, all are connected in series. Okay. Now you can see it. So A1, A2. A1 is the T1 starting, ending is the A2 is this one. Similarly, so A2, T3 is this one, this one. So whatever the current is coming and is going to the this one. Simple series. The current direction A1 is also this direction, A2 also this direction. Both are additive. Then, so we are going to get the number of poles is equal. If the terminals are connected and shown in the figure A, T1, T2, T3, T4 terminals, all the four coils magnetized in the same direction and form the north poles. Okay. The consequent poles, so whatever the poles is connected, this the winding is connected. The current direction, which is the north pole, the current direction is coming the automatically it becomes the south pole. Okay, that is the concept. Consequent poles of the opposite polarity south are formed in between the north poles, giving the total number of poles are 8 and a synchronous speed of 750 rpm runs by the synchronous magnetic field. If the terminals are connected as shown in the figure T1, T2, T3, T4, there will be a total of 4 poles giving the synchronous speed of 15 rpm. If the connection is changed, then we are going to the 4 pole machine becomes. You can see here. So in this case, what we are connected, you can see, dear students. First case we are connected T1 and T4 is taken the supply. Now instead of T4, I connected the T3 taken the output here. Input here. Previous case I taken here. Now we connected the T3. So in this case, what will happen? This is the connection north pole and is coming here. It is connected here north pole and coming here. It is connected here and it is connected instead of here is going this direction. And once again, so here you can see this north pole here. It is the current is going to the north pole. It becomes then a south pole. Next is going to the north pole. Next is coming south pole. Then what is happened? Here these poles, both directions are the here, and you can see the both directions are here, and both directions are here, and you can see. So what will happen? This and this is the same. So then we can say this is the one off, this is the off. So which is the direction is flowing the up direction, we take in the north pole, and current direction is come the south pole. So here you can, this is the south and this is the south. This is the north and part of this is the north. How many poles? 1, 2, 3, 4. So P is equal 4 poles, simply connecting the terminals. Okay. So then what will happen? Automatically it changes its values. Okay. Now in this case you can see that T1 and T2 connected in this direction fashion. But whereas previous case we connected here. Now in this case we connected. So this is this direction, this is the opposite direction. The number of poles becomes to the off. Okay. Now we can say this is a parallel connection. Previous in series connection. Typical torque speed curve, you can see it. How the speed changed. First case when poles are 8 poles, then what is happened? Here you can see the maximum speed developed is at this condition. Once the number of poles changed, so it becomes the number of torque is developed. So this is the speed changed. Okay. So when this case, this is a 8 pole machine. So this is the 4 pole machine. Okay. So this is a starting torque, this is starting torque. With 8 pole we are going to starting torque this one, and 4 poles we are going to starting torque this one. Okay. So with the combination of having the two separate stator windings and using the consequent pole technique, the 4 different speeds are possible in second case. With the combination of the above 2 methods A and B of having the 2 separate windings on the stator by the series and parallel, that is the consequent pole technique, the connection of the coils across the supply 4 distinct speeds can be obtained. Whereas in case of that only 2 speeds are obtained once separate 2 windings are inserted in the stator winding. But whereas in the consequent technique we are going to get the T1, T2, T3, T4. By connecting this series and parallel, we are going to get the 4 variable speeds. Okay. However, the smooth variation of the speed over a wide range is not possible in these techniques. Okay. Same thing we have seen. Let us summarize what we have seen in this class. So far we have discussed, dear students, the speed control of induction motor, by pole changing methods. Okay, I think you have some idea. So thank you for listening my class, dear students.